DSPy employs a modular language model configuration system to establish a foundation for privacy-preserving delegation, where a local model interacts with an external, more powerful LLM while minimizing exposure of sensitive information. This setup leverages the DSPy LM class to define and manage multiple language models, each with specific parameters tailored for their roles in the Papillon system. We are about to examine the initialization and configuration of these language models, including the local model and the external LLM, which will be essential for the subsequent implementation of the Papillon pipeline. The code will reveal how the environment is prepared, with specific attention to the parameters and providers that facilitate this interaction.
Import DSPy. Import Arbor. From Arbor, import Arbor Arbor provider. Arbor server info equals Arbor init hash. Initialize the Arbor server in the background. Port equals 7453. Local LM name qn/qn2 5-1 5b instruct. Local LM equals DSPy LM. Model equals fopeneye/arbor. Local LM name. Provider equals Arbor provider. API base equals Arbor server info. Base URL. Hash Arbor checks to make sure these match the training config. Temperature equals 1, 0. Top P equals 1, 0. Top K equals 1. Repetition penalty. Max tokens equals 2048. DSPy. Configure Elm equals local LM. OpenEye LM equals DSPy. LM model equals OpenEye/GPT-4, 1 mini.
This code establishes the foundational environment for the Papillon privacy-preserving delegation system by configuring two language models with distinct roles. The local model, qn/qn2 5-1 5b instruct, is set up through Arbor's RL framework with specific generation parameters that match the training configuration, including temperature, top P sampling, and token limits. This model is configured as the default LM using DSPy. Configure, meaning it will handle most processing unless overridden. Simultaneously, a more powerful but untrusted external model, GPT-4, 1 mini, is initialized separately for handling redacted requests. The architecture demonstrates a privacy-by-design approach where the local model acts as a privacy gatekeeper, while the external model provides enhanced capabilities. The configuration parameters like temperature equals 1, 0, and top P equals 1, 0 suggest maximum randomness in generation, which is unusual for production, but aligns with the experimental nature of this RL-based optimization. The dual LM setup enables Papillon's core functionality, crafting privacy-preserving requests for external processing while maintaining local control over sensitive data. This pattern is particularly useful in scenarios requiring both computational power and privacy guarantees, though it introduces complexity in managing two distinct model interactions. Let's break it down.
Import DSPy.
Imports the DSPy framework, providing access to its language model LM management and optimization capabilities for programmatic AI workflows.
Import Arbor.
Imports the Arbor module, making its functionality available for use in the current scope.
From Arbor, import Arbor Arbor provider.
Imports Arbor GRPO and Arbor provider classes from the Arbor module, enabling access to these specific components for use in the current code context.
Arbor server info equals Arbor init hash. Initialize the Arbor server in the background.
Calls Arbor init to initialize the Arbor server in the background and stores the returned server information in the variable Arbor server info.
Port equals 7453.
assigns the integer value 7453 to a variable named port, which will be used as a network port number for communication.
Local LM name, qn/qn2, 5-1, 5b instruct.
Assigns the string qn/qn2, 5-1, 5b instruct to the variable local LM name, which appears to be specifying a local language model identifier for use in the DSPy framework.
Local LM equals DSPy. LM
creates a local language model instance using DSPy's LM class. This establishes a language model object that can be configured for specific tasks within the current scope. The variable local LM will hold this instance for subsequent operations.
Model equals fopenI/arbor. Local LM name.
Assigns a string value to the variable model that specifies an OpenAI language model named Arbor with a local model name provided by the variable local LM name. This string follows the format OpenAI/Arbor, local LM name, and appears to be configuring which language model to use in the DSPy framework.
Provider equals Arbor provider.
Creates an instance of Arbor provider and assigns it to the provider parameter. This initializes a provider object that will be used for subsequent operations, with Arbor provider being the specific class handling the provider functionality in this context.
API base equals Arbor server info, base URL.
Assigns the value of the base URL key from the Arbor server info dictionary to the API base variable. This extracts the base URL for the Arbor server from the provided configuration dictionary.
Temperature equals 1, 0.
Sets the temperature parameter to 1, controlling the randomness of text generation in language model operations. Higher values like this produce more diverse and creative outputs, while lower values would generate more deterministic and focused text. This is a common parameter in LM configurations that directly influences the sampling strategy during text generation.
Top P equals 1, 0.
Sets the top P sampling parameter to 1, which controls the cumulative probability threshold for nucleus sampling during text generation. With top P equals 1, 0, the model considers all possible tokens in the vocabulary when sampling, effectively disabling nucleus sampling and allowing the model to choose from the full distribution of possible next tokens.
Top K equals 1.
Sets the top K parameter to -1, which typically configures a model or function to return all possible results without limiting the output count. This is often used in scenarios where you want to retrieve or consider every available option rather than a subset.
Repetition penalty.
Sets the repetition penalty parameter to 1, which controls how strongly the language model should avoid repeating the same phrases or tokens in its output. A value of 1 means no penalty is applied, allowing natural repetition in the generated text.
Max tokens equals 2048.
Sets the maximum token limit to 2048 for the language model operation, controlling the maximum length of generated text or processed input.
DSPy. Configure elm equals local LM.
Configures DSPy to use the specified local language model, local LM, as the default LM for subsequent operations. This sets the global LM that DSPy modules will use unless overridden in a specific context.
OpenAI LM equals DSPy. LM model equals OpenAI/GPT-4, 1 mini.
creates a language model instance using DSPy's LM class, configured to use OpenAI's GPT-4 mini model as specified by the OpenAI/GPT-4 mini model identifier. The resulting object, OpenAI LM, will serve as an interface for interacting with this specific language model through DSPy's framework. This setup establishes a privacy-preserving dual LM architecture, where the local QN model acts as the primary processor, while the external GPT-4 mini handles redacted requests. The local model's configuration through Arbor's RL framework with maximum randomness parameters temperature equals 1, 0, top P equals 1, 0 suggests an experimental approach to privacy-preserving delegation. By setting the local model as the default via DSPy configure, the system ensures most processing happens locally, with the external model only engaged for specific tasks. This pattern balances computational power with privacy control, though it introduces complexity in managing two distinct model interactions. The architecture demonstrates how DSPy's modular LM configuration enables sophisticated privacy-by-design systems like Papillon.
The compiler awakens itself between BootstrapFinetune and the first compile, birthing its own existence.